Hello, welcome to our presentation on Salted Hash's infrastructure solution. This is a presentation by Cloud4.
So for this project, we decided to split up responsibilities into kind of four general areas, that being programming and setting up the web application, architecting and pricing the solution, scaling the infrastructure, and then implementing DevOps.
Exactly. This brief going over the project that we've taken on is the infrastructure and DevOps for a solution that can maintain a load of 31,000 plus locations while being able to provide 1 million plus active users with the content that they need. We'll be using a database to dynamically load the information for this site, handling for updates in the content that is already on the site, and utilizing a lot of the functionality within AWS using the EC2 instances, RDS database, code pipeline, these types of things. And then at the end of our presentation, we'll provide an estimated cost for the year. So what is Salted Hashes? Who are they? What do they do? This is a online cookbook that renovates how you think about food. We're providing the Northern Hemisphere with all your favorite recipes at scale, removing the frictions from meal planning, creating a process to provide cloud-based dietary ideation.
So like Isaac said, this is a full CRUD application for putting your recipes on the web. We have full sign-on working, as well as the ability for users to upload their own recipes. This will go into the database, and as you'll see, users can also upload images, which will be stored on S3 buckets. This way, rather than storing the images on an EC2 instance, which will scale up and scale down, this way all of the EC2 instances will be able to access this bucket and get all the images uploaded by users. Additionally, this is being hosted on an EC2 instance with the flavor of Ubuntu, just because it seems to be a little bit more supported than other flavors of Linux. Another notable decision we made was to use a Postgres database. This is because there's no licensing fee involved, and we're also a little more familiar with it. And then, as you can see here, the recipe was uploaded, and it's right there on the database.
Now, looking at this diagram for our solution, this is the desired solution that we will get to, not necessarily the solution that we have presented to you today. Notable differences is we're currently working in just one availability zone, and we'll be having the next availability zone up and running in our next sprint for this project. Using our CloudFormation, we're able to create that US East 2 availability zone virtual private cloud, within which we're using an application load balancer to scale, as Benjamin said earlier, and we elected to scale horizontally, creating and expanding those fleets depending on those different availability zones, providing users with an EC2 instance that stores the content to an S3 bucket. This is done primarily for the use case of storing images locally, would prevent being able to access those files and those images that are uploaded as we scale up and then back down. Moving on to our cost. As we look at the decisions that we made, that heavily influences the cost. The cost in this situation is the absolute upper bound of how much this solution would cost you for one whole year. So that's 12 months of using these EC2 instances. We made the decision to have an upfront cost if that's something that you would not like. It would be more expensive actually to pay for this by month. We are using the Ohio and London availability zones, a T3A small EC2 instance. One of the benefits to using an instance of this type is that it has burstability. So we're able to have short and quick bursts of power from the instance, as opposed to having a very heavy computational machine. We're using a daily spike accounting for 17.5 hours of use, because we know that our users will be asleep for a good portion of the day as well. Code deploy, code pipeline, these are pretty inexpensive. You are only able to pay for these monthly. However, some of the decisions that we made for this is to have 4 active pipeline users, and to have an ability to have 10 on-premise instances with 120 deployments throughout the year.
Great. So then we also, using S3 and adding 4 terabytes of storage for that will enable us to have up to 1 million photos on this S3 bucket, and then it'll cost very little if we ever need to increase the storage for that bucket. Additionally, this having the S3 brings down dramatically the cost of the EC2 instance, because that's storage that we don't need to pay for on the EC2, and that's a little more expensive on an EC2 instance. And then RDS is by far the most expensive component of this infrastructure, just because it's a maintained service by AWS. But the benefits of this are that we just don't have to worry as much about the maintenance and security and the patching of this RDS server.
Yeah, the total price for a solution like this, as we said, over a whole year is going to be $182,400. And this is without having any bottlenecks or any need to go above and beyond the diagram that we were showing you earlier. Here in this demonstration, we're showing that the code that we have in production is able to be updated and changed as we use the code pipeline and code deploy in AWS. Here we're just waiting for this to update. And this is run through GitHub. Here we see code pipeline demo is the header that has been changed, and this is just some trusty evidence that we were able to achieve this auto scaling and load balancing as well. As traffic increases, this will be sure to review those changes and be able to update us how that goes.
All right, so that is our solution that we've come up with. Of course, not everything is implemented in our solution diagram, but that's something that we hope to flesh out on future iterations. Thank you for your time. We hope you enjoyed.